Hi everyone. So now we're going to start to review Newton's laws of motion. This was the handout you received before the March break that has the statements to all three of his laws. I also wrote down some symbolic summaries on the board. Hopefully you copied those down. I also had those posted at the front of the room as posters. I guess you won't get that in distance learning unless you make the posters themselves to have in front of you all the time. But in this video, we're going to focus on the first law. So here is a statement to Newton's first law. An object will remain at rest or in uniform motion unless acted on by unbalanced external forces. So that sentence, I tried to simplify that by summarizing it in one or two more shorter statements. So here's one way I can kind of get to the point of Newton's first law. If the forces acting on an object are all balanced with each other, then the object will not accelerate. Okay, so it'll either stay at rest or it will stay in uniform motion, which is constant velocity. Okay, as long as the forces are balanced, and vice versa. If you read a question and it says that the object is moving at constant velocity, then you can know that the forces are balanced. So when you draw your free body diagram, everything's got to balance out. On the flip side, we can also say it like this, that if the forces acting on an object are unbalanced, then the object is going to accelerate. So if we have two forces acting on an object in opposite directions, one of them is bigger than the other one, that one's going to win, and it's going to cause the object to accelerate in that direction. So that was Newton's first law. And here I've loaded up a Phet Simulation. This is produced by the University of Colorado, and they made it free online. It's very generous of them. I can show you a lot of physics concepts through their simulations. So for Newton's first law, it's fairly straightforward. I have an object, a crate, that's on a skateboard with wheels, and that's just to tell you that we're not going to have friction in this scenario. The wheels are going to allow this box to move smoothly without any frictional forces. So right now, the object is at rest, and it's going to stay at rest as long as my force is 0 newtons. You can see where my mouse is here. I've got 0 newtons applied to it. That doesn't mean there are no forces at all. There is the force of gravity acting down on the box. There is the normal force acting upwards on the box, but they balance each other out. Okay, they balance each other out, and so there's no acceleration. However, once I unbalance the forces, so I'm going to click on this dummy and I'm going to drag him to the box, and now it's going to push the box. You can see the amount of newtons going up. Well, now this box is accelerating because the forces are not balanced. And now he's let go. Since he's let go, there's no more acceleration. So this object is going to just move and stay in this motion, constant velocity, forever, or until I unbalance the forces again. All right, let's unbalance the forces again. Let's slow this down. There we go. And now you can see the speed meter at the top of the screen. The speed is slowing down because the forces are unbalanced, so it's accelerating. Now I'm going to, let's see, can I get rid of him? Yeah, now I let go. He lets go, and you can see the speed meter, it's not moving anymore. Okay, so now the forces are balanced again, so the object is moving at a constant velocity. And that's the gist of it. Okay, balanced forces means it moves at constant velocity, no acceleration. Unbalanced forces means it will accelerate. That's Newton's first law. All right, the next video we'll talk about the second law. Actually, I will also remind you that before March break, you were given a whole list of true and false questions for all three of Newton's first laws. So you may want to take a look at this again. It's posted on Google Classroom as well if you go back earlier in February when we did it. It looks like the answers are still there, so you can read it to try to understand. All right, we'll see you in the Newton's second law video.